In this video, I'd like to talk about the math question of the day for February 4th, 2023. And with this problem, we have two numbers that have a sum of 91 and a product of 1200. What are the two numbers? And to answer a question like this, you need to understand the basics of Algebra 1, maybe even a little bit of Algebra 2, and how to deal with word problems and defining variables. So at this point, go ahead and pause the video, and after spending at least a couple minutes, see if you can solve this yourself. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, we can start going through it together. And as always, if you have any suggestions for future questions of the day, feel free to leave a comment down below. Now, there are two main approaches to this. One is that we can just guess and check that two numbers have to add to 91 and they have to multiply to 1200. But the problem with that approach is that it can be a little bit tedious, especially if these numbers are bigger. And it might take a while to guess the correct answer. So a more straightforward approach is to define variables. We can say that these two numbers, we can just call them x and y, have a sum of 91, so that we can write x plus y is 91, and they have a product of 1200. Product just means multiplication, so x times y is 1200. Now we have two equations and two unknown variables, so we can actually solve this. And we can take this first equation and solve it for one of the variables. Let's subtract x on each side. We get that y is 91 minus x. And once we solve this for y, we can substitute into the second equation. And by doing so, we get x multiplied by y, which is now 91 minus x. This is equal to 1200. And distributing, we get 91x minus x squared is equal to 1200, which is a quadratic equation. And to solve a quadratic, the general strategy is to set one side of the equation equal to 0. So let's move everything to the right, so that on the left we'll get 0. We're subtracting 91x and we're adding x squared. We get 0 is x squared minus 91x plus 1200. And with this quadratic, we could try to factor it, but ultimately that will lead to a very tedious approach. So the more straightforward approach is to use the quadratic formula. And we know for some general quadratic that when we have ax squared plus bx plus c is equal to 0, that we can solve this for x, so that x is the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by twice a. And it looks like in our case that a, the coefficient on x squared, is 1, b is negative 91, and c is 1200. So we will get big numbers here, but we can use the calculator to deal with those and compute. So x is the opposite of 91, the opposite of negative 91, so that's positive 91, plus or minus the square root of b squared, we get minus 91 squared, minus 4 times by a, which is 1, times by c, which is 1200. And keep in mind that b, when we square it, this is always going to be positive, whether it starts negative or positive. And all of this is divided by twice a, which in this case is just 2. And if we simplify this, we get 91 plus or minus 91 squared would be 8,281, and 4 times 1200, that's just 4,800. So we're subtracting 4,800. All this is divided by 2. And if we simplify this, this just becomes the square root of 3,481, which you may or may not recognize as a perfect square, but it is a perfect square. In fact, this is just equal to 59. So we can now rewrite everything. We have 91 plus or minus 59, all divided by 2. And if we add first, let's move the 1 to the 59, we get 90 plus 60, which is 150 divided by 2, so that'll be 75. And the other one would be 91 minus 59. 90 minus 60 is 30, and there's another 2 there, so that's 32. We divide that by 2. So the two solutions we're looking for are 75 and 16. And let's go back up to the original question and make sure that makes sense. We found 75 and 16. It looks like they do add to 91, and when we multiply these together, they do give us 1200. So these are the two solutions to this word problem here.